So we go ahead and we graph this system by graphing each of those two lines individually. And when we do so, you can see the results over there, the lines we get, but of course that's not our solution yet, right? It still says what is the solution. We use the graph to do that by looking to see where do they intersect, and we give the coordinates of that point, remember, which in this case is going to be at 4, 6. And so that's your final answer. Out of all that work is 4, 6. Now, we focused on solving by graphing with this one and the problems that we saw in the last couple of days, but today we're going to continue solving, but we're now going to see how we can take that same system of equations and we're going to be able to solve this system without graphing. That is, we're going to solve it algebraically. For most of you, this should be practice and review, just bringing back some really old memories, old techniques from Algebra 1 kind of thing. If it turns out that you haven't seen it before, well, then consider this your crash course. All right, so the method that we're going to be talking about today is called the substitution method. The substitution method basically says that if I know what one of the variables equals, I can plug that in for the variable in the other equation. Let's see what I mean here. So like that first one, I know that y equals 2x minus 2. So I can take what y equals and plug it in for y in the other equation. That is, I am substituting it in to the other equation. And so when I do that, then my first line of work is going to be 2x minus 2 equals a negative 1/4 x plus 7. So what we've done there, and what's really going to help us here, is that we took what was two equations with two different variables, and we turned it into one equation with one variable. That is, we turned it into something that we can solve easily. Now, about the solution for this though, because there's that 1/4 in there, and sometimes that throws people off. Like, as you're looking at this equation and you want to solve it, what's your first step? Think about what would your first step be? And most of you right now are thinking, at least if past tendencies are any indication, most of you are thinking probably that you want to add that 1/4 x to both sides. And yes, you can do that. But realize then that you're going to have to add 1/4 x to 2x. And for some of you, that's no problem. And for others of you, you just cried a little bit inside. Well, if you are in that latter camp, there's actually an easy way to deal with that. Anytime you have an equation like this that has a fraction in it, you could start by getting rid of that fraction out of the whole equation. The way to do that is you multiply everything on both sides by the denominator of that fraction. So in this case, I'm going to multiply everything on both sides by 4. Now again, you don't have to make this your first step in order to solve this, but it can make it easier for many people. So I want to show you this technique. If we do that then, remember I'm multiplying everything by that, so it becomes 8x minus 8 equals, now you're doing that negative 1/4 times 4. Now just show you out the long way, why does this work the way it does? If I take negative 1/4 and I multiply it by 4, remember 4 is a fraction, is 4 over 1. And in order to multiply fractions, I multiply straight across the top, straight across the bottom. So that ends up giving me a negative 4 over 4, or in other words, negative 1. And so when I do that multiplication over here, my negative 1x, well that's just negative x, plus multiply the 7 by 4 as well, we get 28. Now that equation looks a lot easier to solve if the fraction was messing with your head. So go ahead and finish solving it from there. And so usually at this point, most people will add x to both sides. You don't have to start by adding x to both sides, but it is the most common. So I'm going to run with it. But then if you do start by adding x to both sides, your next step, well, that one's determined. I got to add that 8 in order to get the x's by themselves on the left side. And notice how I'm showing the work. Yes, this is what I want to see on your own paper. Every step I'm showing what I'm doing to both sides, and then I'm showing what that gives me when I do it. I want to see that process shown throughout your algebra. That's how we avoid mistakes and how we communicate clearly through this. All right, now having done that, you'll remember what our solution was when we solved this by graphing though, right? Our answer was not 4. It was part of our answer, but our answer wasn't just 4. We also had to find a y value so we could give a coordinate pair, the point. So we still need to find the y. And so what we're going to do in order to accomplish that is we are going to take our value of x and we're again going to substitute it back into an equation. Now you can substitute it back into either one. You can plug it in for the x in the first equation or plug it in for x in the second equation. It doesn't matter which one you pick. They both will give you the same answer. Usually it's just a matter of which one looks like it's going to be easier. Yeah, and in this case I think the top one's looking easier. So I'm going to plug it into the top one. So we are now going to go y equals 2, plug in the 4 for x, minus 2. And we're just going to solve that to see what that gives us. So y equals 8 minus 2, and therefore y equals 6. Thank goodness it's exactly what we found before, right? And yes, it should always give us what we found either way. Both methods, graphing and the algebraic methods, will always give us the same solutions if we do them correctly. And so, yes, we get our final answer again of 4, 6. I still provide my answer as a coordinate pair. That substitution method, seeing the whole thing in action, everything else we do, practicing it, is just going to be a variation and seeing how it applies in different situations. Now in the first problem we did, they both were y equals. So basically we set them equal to each other when we substituted. Notice this one's going to work a little differently. Only one of the equations is set up to be what y equals. In this case we're told that y equals the x plus 5. Well then what I have to do in order to do this is take that x plus 5 and substitute it in for y in the other equation. And so when we do that then our first line of work is going to be 2x minus 3. Now instead of writing y, I write what y equals. So I go parentheses x plus 5 equals the negative 13. And then we just solve this for x from there. Now check that your first line of work is looking good. Because notice what I'm actually distributing into the parentheses. I'm actually distributing in that negative 3. And so the common error here, if we aren't careful, is that sign being off. So make sure that you had minus 3x minus 15 there. And then continue solving from there. And so when you do all that work, you should be getting an x equals negative 2. Once we found that x, remember, we still have to take one more step. I need to take that x and plug it back into one of the original equations. And again, you can plug it into either one. You'll get the same value of y out of it. But in this case, one of them is definitely easier than the other one. Because if I tried to plug that in for x here, I'd have a bit of algebra to do. Whereas if I plug it in up here, the equation is y equals. When I plug it in there, it tells me what y equals, which is what I want to know. So I'm definitely going to want to plug it into that first one. So I'm going to do negative 2 plus 5 equals y, so therefore 3 equals y. And so our answer here is negative 2, 3. In this case, neither of the equations is y equals, but we do have one of them that is x equals. And so I can use that still. So I take what x equals and I'm going to plug that in for x. And so this is what it should be looking like when we do that. Solve from there. And so when all said and done for that first set of work, we end up finding that y equals 4. Remember, we then still have to find the x, so plug that back into either of the original equations. Go from there. And when we do that, you notice we end up finding here that x equals -2. A note about your work. Notice as I'm doing my algebra over here, I'm trying to line up all my equal signs vertically so it's neat and easy to follow. And I'm actually writing out what did I plug in where to get that x value. And I'm actually showing that work. Sometimes I'll see people where they'll do all this beautiful work over here, and then they just go straight to x equals -2. We got to show that work as well, because mistakes can happen on that part as well. There's just not as much to write out. Now, we remember give our answer as a coordinate pair, as a point. Which number did you write first? It can be a little bit of a trip-up point here if we aren't careful. We have to still write the x first. You found the y first, though, which is what makes it tempting to put that first. And so make sure you're just going x, then y. So in this case, -2, then the 4. Now, the tricky thing with this one, at least potentially, is some people get caught up in the options. We have one of them that's y equals. We have one of them that's x equals. How do I know what to use? You actually have a choice. You can go with either one of them. And so your first line would look like one of those. You don't need to do both of them. You just need to give one of those as a way to be able to see that first line and then go with it and solve it from there. All right, and then so when you do that work, this is what it should be looking like. Now I went ahead and worked it out for both of them so you could see what all the work would look like. And yeah, it turns out you could actually even do the work the long way for both of them to be able to find your answer, but I wouldn't expect you to. Once you found either your x or your y, just plug it into one of the original equations. Either way, your answer, remember, give it as a coordinate pair, should be 7, -5.